Hi everybody. Hello everyone. Welcome to the NEET Byte session, guys. Uh, I'm seeing few people have joined. Hello SK. Hi Seema. Hello Aditya. Yes. Hi Meghna. Yes. So guys, as promised that we are going to take up the fluid mechanics part 2. So in the first part we have discussed about the pressure and like viscosity numericals. Okay, and this time we are going to discuss about the Bernoulli's and the equation of continuity. These topics we are going to discuss, and we are going to take a few numericals on that, right? So yes, can we just start off the session, guys? Okay, so from my side, guys, a great evening. Okay, and hello Nikki, hello Minakshi, everybody. Yes, so I'll just give you a brief idea of what we are going to discuss. Okay, so guys, according to the first of all, I'm going to discuss about the equation of continuity. Equation of continuity says that the volume of liquid entering per second, okay, you are just dividing it with the time, okay, so volume of the liquid entering per second has to be equals to volume of the liquid coming out, okay, per second. This is the equation of continuity says. So if I do have a pipe, right, which has a different areas at both the ends, like suppose the area here is a1 and the area here is a2, right, and the velocity of the liquid that is being entered into the pipe is suppose v1 here, okay, and it is like the velocity by which the liquid is coming out is v2. So according to the equation of continuity, what we suggest is that product of a1 v1 has to be equals to a2 v2. Okay, this is the relation that we are going to use in the numericals, and that says that the volume of the water or any liquid that is coming out, or you can say entering, per second has to be constant, or what you can say that a into v means the product of area and the velocity has to be constant. This is what we learned from the equation of continuity. Okay, so this is the things, okay, equation of continuity. And the second one here, I'm going to discuss about the Bernoulli's theorem. Bernoulli's theorem is nothing but it is based on the conservation of energy. Okay, when a liquid is in the motion, so what happens? It has three types of energy. One is a pressure energy, one is the pressure energy, and one is the potential energy, and the last one is the kinetic energy. So these are the three energies that is possessed by a liquid whenever a liquid is in the motion. Okay, so what happens is the sum of these three energies has to be constant. If you take the cross section of the pipe, any cross section at any height, so we like I'm going to take up this one. So any cross section you are taking it here, so the energy, the total energy is constant everywhere. Here suppose this is te means total energy, you can write it as suppose a. Here also the energy would be a, here also the energy would be, everywhere it should be constant. Okay, Rameshwar, oh sorry, Shamsher. Okay, Shamsher just asking to explain the kinematics. Kinematics we have already done with that. We had a previous YouTube session, so you can watch it over there. Okay, yes, so the sum of the total energies means this one, the pressure energy, potential energy, and the kinetic energy has to be constant. So generally how we write it here, I'm going to tell you the sum of the potential energy, okay, kinetic energy, and the pressure energy, okay, has to be constant. Or generally what we do is we generally take the values per unit volume, energies per unit volume. So if you're writing it in the form of energies per unit volume, so that would be rho gh plus half rho v square plus rho gh again. Okay, this has to be constant. So this is nothing but the pressure and potential energy here, and this is nothing but the pressure energy. Okay, so this equation is based on the law of conservation of energy. So we are going to use this. We are going to use this in a lot of the numericals. Okay, so now let's just take a few numericals, because all the numericals will be based on basically on these two things. Okay, so let me just start with the numericals, guys. So we do have a numerical here that says a wind with a speed 40 meter per second blows parallel to the roof of a house. The area of the roof is 250 meters square. Assuming that the pressure inside the house is atmospheric pressure, pressure inside the house is atmosphere pressure, yes, the force exerted by the wind on the roof and the direction of the force will be, and we do have the density of the air that is being given to us. Okay, so what we are going to do, suppose this is, I'm going to just make an illustration for all of you guys. So this is, suppose, I'm going to make, guys, I'm very bad at drawing, seriously, so I'm just making a small illustration here. So yes, what is happening here, the wind is blowing at the top of the roof. Okay, and here also inside the home, the pressure, I'm going to just make it as p naught, because they have already told us that the pressure inside the house is p naught, means the atmospheric pressure. It's already given in the question. Okay, so as the wind is blowing here with a speed of 40 meter per second, okay, so we do have a different pressure here, because pressure is directly or inversely, means we don't know the relation actually. According to the Bernoulli, they are actually inversely proportional to each other. So pressure must be different here at the top. So this pressure is consist of the atmospheric as well as because of the wind blowing. So what we are going to do is, we are going to put the, just a moment, we are going to put the Bernoulli's theorem here. So suppose this is a point A, I'm going to take it, and this is the point B, I'm going to take it. So if we are putting, if you're just applying the Bernoulli's theorem on the 2 points, how we are going to do? So at the top of the roof, what all things we do have, that is half rho v square, right, because of the kinetic energy, plus what is the pressure, we don't know, we are going to take it as only P. And as you can see, we are just taking the same height, means just below this, means these points are almost at the same level. So that's why we're not considering the potential energy here. So inside the pressure is p naught, and there is no wind blowing, so all the energies would be zero. So how can I write it here? P minus p naught is equals to minus half rho v square, and we are generally considering the mod here. So P minus P naught of mod means the delta P, means the pressure difference is nothing but half rho V square. So we need to just calculate the force that is being acted. Okay, can you tell me from where the force being acted here? From where the force will be acting? From the top or from the down? Anybody, guys? See, potential energy we are not considering. Let me just tell you here. Potential energy we are not considering, because these 2 points means, just see, I have, suppose I have this one here. So this is at this point is here, and this point is exactly below this one. So they are almost at the same height. That's why we are not considering the potential energy. They are almost at the same height. Okay, so this is the reason. So if you wanted to calculate the force here, force would be, just a moment, the force would be delta P, means pressure into area, isn't it? And delta P is already given to us, that is half rho V square into area. Area is already given to us. So you just put the values and calculate the answer here. Let me just do it. This is half rho V square. Rho is given to you. So force is nothing but delta P into A is equals to half rho is given to us 1.2 kg per meter cube. V square means 40 into 40, 40 meter per second by which the wind is blowing. And we do have the area. Area is given to us as 250 meter square, right? So what you are going to do here, it would be, okay, or okay, let it be, this would be 0.6, right? 0.6 into 1600 into 250. So that would be 960 into 250, and once you just multiply these, okay, 24 into 10 to the power 4, or you can write it in this way, right? This is the amount of force that is being acted from the bottom to the top. Why from the bottom to the top? Because where the velocity is more, the pressure has to be less, and here the pressure has to be high. So body always move from a pressure of high pressure to the low pressure. This is why the force is being acted from the bottom. Okay, so this is how you have to solve it. So which option should be correct, guys? The option, the force will be right. Okay, so that in the upward direction, it is acting in the upward direction, not in the downward direction, right? So this is like a pretty, I can say a pretty difficult as compared to other questions, because generally the questions comes, they will give you some equation of continuity and all that, but this you have to just put a little more brain, that's all. So yes, this is how you have to do it. Now we do have another question, guys. The cylindrical tube of a spray pump has a radius r, one end of which has n fine holes. So let me just make a pump like this one, cylindrical tube for you. Okay, so I do have a, okay, so I do have a n holes here, n number of holes at another end. These are the n number of holes. Okay, and this cylinder has r radius at one side, and another end it has n number of radius, and each hole is having a radius of small r. If the speed of the liquid in the tube is v, means the liquid by which it is being entered at this end would be v. So you need to calculate the speed of the ejection of the fluid through the holes. Any one of the hole you can just consider it, right? So if we apply the equation of continuity, means the amount of liquid that is being entered at one end has to be equals to the amount of the liquid that is coming out per second at another end has to be equal. So nothing but A1 V1 is equals to A2 V2, isn't it? What is the area at this side? Pi r square. V is already given. What is the area of this side? You have to consider the n amount of holes, because water is coming out from everywhere, means all the holes, right? So we just need to multiply with the n and each area, each whole area, and we just need to calculate the velocity here, right? How would you do that? See, pi will get cancelled out, and the small v is coming out to be v r square upon n r square, isn't it? Right? So guys, this is the one here. Which option should be correct? V r square upon n r square. So A option should be the correct one, right? Right, guys? Any doubt in this? Ejection is my, like, by what velocity the water is coming out from the pipe. That is the ejection. Yeah, this one was easy. Exactly, Dhruv. So I do have another question here. A fluid is in a streamlined flow across a horizontal pipe of a variable area of cross section, for which of the following statements is correct? The velocity is minimum at the narrowest part of the pipe, and the pressure is minimum at the widest part of the pipe. B option is the velocity is maximum at the narrowest part of the pipe, and the pressure is maximum at the widest part of the pipe. And other options are velocity and pressure both are maximum at the narrowest part of the pipe, or the velocity and pressure both are maximum at the widest part of the pipe. So which option according to you should be correct? So if we just if you just recollect whatever I have taught you, so that is A into V has to be constant, right? That's what equation of continuity suggests, right? So in this case, you know that whenever the area is more, the velocity has to be less. And this pipe is nothing but the non-uniform cross section, means the area is being changing everywhere, right? So wherever the area is more, the velocity has to be less, and wherever the area is less, the velocity has to be more, right? So we do have some option here. This cannot be correct. It is minimum and narrowest. So this cannot be correct. The velocity is maximum at the narrowest part of the pipe. That is correct, the first statement. And the pressure is maximum at the widest part of the pipe. So how can we relate this one? You know that at the widest pipe, the area is more. Area is more means the velocity is less. Wherever the velocity is less, the pressure has to be more. This is what the Bernoulli suggested. Okay, so according to this, all these factors, if you just collate all these factors that we have thought right away, so we just will come up with a conclusion that B has to be correct, because whenever the area is more, the velocity has to be less, and when the velocity is low, or when the velocity is less, so at that point of time the pressure has to be more. So this is the thing, guys. Okay, so I do have, I guess, only the last question remaining here. So yeah, so guys, this is one of very important topic, the Stokes law and the terminal velocity. You might get numerical on this one as well. So yes, the terminal velocity VR of a small steel ball of a radius r falling under the gravity through a column of viscous liquid of coefficient of viscosity eta depends on the mass of the ball m, acceleration due to gravity g, and the coefficient of viscosity eta, and the radius r. So what is happening here? There is a ball, steel ball, having a radius r. It is being falling down, okay, under a viscous liquid. This is being falling down under a viscous liquid. And what is happening here? You just need to figure out which one of the following relation dimensionally are correct. So guys, instead of checking out every option, this will take a lot of time. So what you can do is, you can just make the FBD of this figure. What is happening here? Suppose this is a ball. All the forces, you know that one is the mg, means the weight of the body is acting like in this way, right, in the downward direction. And here you know that the bind force would be acting, and one more force would be acting according to the Stokes law, and that is the viscous drag, that is 6 pi eta rv. That's what we do, right? That's what we do, right? So what is happening here? How do we calculate the terminal velocity? Terminal velocity would be achieved when the entire force is balanced by the, means the upward force and the downward force would be balanced out each other, right? Or you can say the net force on the body has to be zero. So how can we just write it here, that buoyant force plus 6 pi eta rv is equals to mg, and 6 pi eta rv is equals to mg minus buoyant force. So guys, I just need to ask you one important thing here. Suppose you know that the weight of a body can be easily can be only subtracted with the weight only. So buoyant force is what? Buoyant force is nothing but the weight. It has the same dimension of the weight, isn't it? So we need to just subtract the weight minus weight. So this, the, just a moment, dimensions here that are coming is nothing but of the weight only. Okay, so I can just put the weight, because a physical quantity will be subtracted from the similar physical quantity that you must have learned from this dimensional analysis chapter, right? So here it is 6 pi eta rv. So if you just calculate v from here, so what you are going to do, is v is equals to, or you can say this directly proportional, because all these things are the constant, right? So v is directly proportional to, or the proportional here is eta r. Okay, so these are the factors on which it is being dependent on, right? So it is dependent on weight, means mass, gravity, and eta means the coefficient of viscosity and the radius of the ball. So here Which one should be correct? The C option. You can see here the C option is matching with our answer. The only thing that here you have to just remember, first of all, the how you calculate the terminal velocity. And guys, people who have seen like how you drive the terminal velocity, only those people are able to do it in a proper time. Otherwise, that's why I recommend, somebody was asking on like in the previous session, I guess, sir, do the derivations are important? Are the derivation important in the NEET as well? Yes, they are, because these kind of questions you might get. Okay, so this is the thing, guys. So option C has to be correct here. So yes, guys, so that's for questions that we have taken today from the last year of AIPMT and NEET. So guys, that's all from my side, and thank you so much for attending the session, and you guys can just check out these links for more detail. Okay, thank you so much. Bye bye, take care.